the one we're going to do today. Again, it talks about the introduction. I just added some content in there last night about the components that we're using in this demo. So we've got LLama-cpp. This makes it easy to use Python in use with AI. Minio, which allows us to connect to S3 storage so that it can go off and look at PDFs or any data to interrogate it. We've got Minio, Milvus Vector Database, and Streamlit, which will be our front-end facing part of the application with Streamlit. And we have an etc database, same as what's used within OpenShift. So again, in the first part of the lab, it's always about getting access to the system. So we're SSH to the console, which I've already done here. We'll get to the OpenShift GUI interface, which I have just here. And then we will connect the command line interface from our PuTTY session into our GUI, so we can run commands directly to OpenShift. So then we're going to build the Llama container from scratch. We're going to compile that at the same time. So there is going to be a delay of about 4 minutes while we wait for that to happen. And that goes off to GitHub. It takes the source, and OpenShift actually compiles that and does all the container creation itself. So it's very easy to do, but it is just going to take a couple of minutes. We then go on and deploy a vector database, Milvus, and then we do some RAG content on it. So once again, for each, we've got the video recording that you can go through. Again, anything in blue, you just click to copy and paste. So the assumptions again are that we've got the OpenShift console, the IP address of the Bastion, and the kept user password. Okay, so we've already done this part. What I'm going to need to do is just log into the OpenShift GUI, grab the kept user password to do that. And then we're going to grab that token. So copy login command. Which means I need to log in again to make sure I've got permission for that. And this time we can display the token. Copy and paste that OpenShift login command. Come back to our PuTTY interface, and then that logs us into OpenShift and tells us we've got access to the 71 projects. We're currently in the default project. So now we're logged in. So it takes us through some description. It says, don't mistake Llama-cpp for a Llama large language model. It's not. This is part of the source that allows us to connect Python to the AI models. And although it was built originally for Llama, it can use a large list of large language models, including the Granite IBM stuff that was released just recently. Now, in here, under section 3, there's 3 different versions. So the first one we did in the lab last month was we downloaded it from GitHub and we compiled it on the Bastion server. Now the thing with that is it's quite big, so it needed about 20 gig of memory, and we don't tend to have 20 gig of memory on our Bastion servers. So we've adapted that last week. So the compilation is done within OpenShift itself, which actually makes it a lot quicker, a lot easier. And of course, we don't need that memory on the Bastion server. So just saying, you can do it either way. If you've got lots of memory available to you, you can go through step 3.1 and 3.2, where we get the containers and we compile it manually. But if you just want to go to the quick way, which we'll do today, go through to item 3.5. Here we go. So we're going to build and deploy the LLama-cpp application directly within OpenShift. So we install Git first. I think it'll probably already be installed on this system. Save us a little bit of time. Now we're going to clone the project from GitHub. Okay, that's done. Then changing to that new directory that we've created. Going to create a new project within OpenShift. We call it AI. So it's now using the AI project. Good. Now we've got a YAML file which describes what we're building. Now in this YAML file, gives you all the information to build the container and the application. So it's telling us to actually use the Mistral large language model in this case, but there's other YAML files in there to use different. You can choose very quick and easy to change the large language model, because where you might get generic models, you can get others that are quite specific for different needs. So it's very easy to do that. So what have we done here? We've OC applied that YAML file, so it's created the MMA application. It's created a service, and the service is the networking point within OpenShift so that it can communicate with other microservices. And then it's created a route. And within OpenShift, the service gives it the networking within OpenShift, and then the route gives it the access to the outside world, meaning that users can get it from outside of OpenShift. So at this point, we can run an OC get pods, just like we did on the sock shop earlier on, and we can see we've got 2 pods here. MMA build, and that's what's running at the moment. So it's actually going through and getting the source, compiling it, creating it, and then it's going to create the MMA AI container underneath. As I say, this is going to take about 4 minutes. If I do a watch on OC get pods, then it'll just check it every couple of seconds, and when it's ready, in about 3 minutes time, the top one that says running at the moment will go to complete, and then we will find just before the end, the lower one will say there's an error just as it finalizes it, and then it'll go to running, and at that point we'll be able to access it from within OpenShift, just like do ChatGPT or Google Claude or any of the others. Difference being, of course, this is on your hardware in your data center, private, not going out to the internet, not having other people train and learn on your data and your intellectual property. So if I drop back down to the OpenShift GUI, and we're in the developer view, because in OpenShift you get developer or administrator depending on your role. So if we're in the developer view and we're in the project AI, which we just created, then this is the container and the application that we're creating. And really, yes, we cloned it. We used a git clone to bring the project down to get access and create the directory. But all we did to actually create this application was an OC apply command on that YAML file, because the YAML contains everything we need for it. Now, if we click on that, then we can also view the logs, so we can watch it being built. And like I say, that's going to take about 4 minutes. About 4 minutes, I would say. I did mention in the sock shop, this is light blue when it's running, when it's building. It turns to dark blue when it's ready. And we're on 3 minutes now, so we've only got a minute to go. All right, okay, yeah, it's probably already done then. I don't think it is. Yeah, it's not quite there yet. So maybe it's just getting ready. And I've tried it in the past, it's been about 4 minute mark. There it goes, it's turned dark blue now, hasn't it? There we go, here's our application. Okay. What it says in the tutorial online is you can take this time to go and look at what LLama-cpp is in Wikipedia, where there's lots of information in there. So now we have an interface somewhat similar to ChatGPT or Google Claude or any other sort of chatbot type thing. We have a couple of different options. We can say here, we can give it a persona. We can say, okay, pretend you're a top Italian chef, for instance. And then we could come down to the question. So we give it some context, if you like. And we can say, what is the best dish in the world? So it responds quite quickly, faster than reading speed, or at least faster than I can read it, at least. And as you might expect, as we've told it to think as a persona, as an Italian chef, it's surprisingly enough, it comes back with an Italian dish, that's the best one in the world. However, if we reset that and go back, and now maybe say, change it to a British chef. Now, it doesn't always give the same answer, this kind of thing, right? Because it kind of thinks different things, but what is the best dish in the world? So it says, as a top British chef, what are we talking about today? Fish and chips, right? Now, I'm not sure. I like fish and chips, but I'm not sure it's the best dish in the world. Look, doing this last night, it came back with roast beef and Yorkshire pudding for, you know, Sunday roast dinners and so on and so forth. So it does come back at different things. But the point is that you can tell it to think from somebody else's persona. Yeah, you can say, you're an engineer, explain this. Or you could say, you're a salesman, explain this, right? And you're going to get very different explanations. You can wait. Yeah, not very good typing standing up. Pretend you're a great computer architect. Why should I use AI close to my data? Why do I want to use AI close to my data? Efficiency, low latency, resource utilization. So it's what are IBM Power systems best known for? So it's not bad. I think it does come up and tell you the tokens per second if you're into this, and you know, sense. But this is just running with no GPUs. It's just just a few cores there. This is running at 18 tokens per second. Like I say, we've got a slide later on about small. We talk about large language models, but there's quite an essence now for small language models. And again, when we're talking about putting AI at the edge, and maybe even our S1012 half, rack server and so on and so forth, putting no GPUs in there, running it on Power10 at the edge, you can put in an AI anywhere. So before I go on and start looking at the next point, anybody want to ask it anything? So it's actually getting it from the large language model itself. So the model, I don't know about this one, I guess it's probably about 4.6 gig, and it's been trained on what, 12 million tokens, I think it says in the slide that's coming up. I don't know how they get so much information in such a small space. Some of the models, so some of them sort of came out in 2021, for instance. So they've got no idea of what today's date is. They don't access the internet. So if you ask it a question that's happened after it was trained, it really has no idea. The Granite ones were obviously just a few weeks ago, so they've got a lot more in there. But you can, when you design your application, you can say only use information from the model, or you can say if you don't find the answer in your model, then you can go off to the internet and find it as well. So the choice is yours. One of the use cases that I share later on is a chatbot that gets its information and its knowledge from the company's own private data. So they didn't want to use a public type source, because they didn't want to give their data away. They didn't want other people training against their intellectual property and data. And so they used Watson-X locally on site to create their own chatbot. So they'd be working on their own data, and it was all private, because that's what big enterprises and corporations really want. You can train them, yes. Okay, so to do the training, you really do need GPUs. Okay, so because we had GPUs with Power 9, we don't with Power 10. Power 10 is best for inferencing when it's already got a trained model, and it uses that data. Say our storage friends across the way there got GPUs in HCI Fusion, and we have references and use cases and customers actually using it. So they do the training on HCI Fusion with the GPUs, and then they are connected and they do the inferencing, the stuff that I'm showing you now on the Power side. And because Power is very often close to the data, that's kind of why you want to do AI close to the data. You've got reduced network, increased security, that good stuff. Okay, so now we've got the use of our AI locally. We're not paying a subscription to anybody else. They're not getting access to our data. It's all private. We can do it on our own data. That's all good. Scroll through to where we are. So the next part, the Retrieval-Augmented-Generation. So this is where we're going to deploy a vector database. Now, a vector database is kind of unstructured. It's not like an Oracle or a DB2 database where everything's in indexes and everything. It's just vaguely got relations around it. So it's easy to gather and say, well, this word doesn't only mean this word, but it means all these other things as well. So a couple of common ones, there's lots of them, but a couple of common ones is Milvus that we'll deploy here. ChromaDB, I often see used quite a lot as well. They're all supported on Power. So for this instance, I'm going to add the RAG capabilities to the existing application. And to do that, again, I'm just going to apply this Milvus YAML file. So it's gone off and it's deployed the application. it's created, looks like an ETC service, the service which is the internal networking for OpenShift, and then sure to have a root here as well. So it's deployed everything with one command. And when that's happened, this was our original application, the LLama-cpp, and this is what it's hopefully added. So let's see if that's there now. Here we go. So this is our original application, and now it's added the Milvus database, it's added an ETC database, and the Minio deployment, which as I said is the S3. So this can access any data using S3 storage technology. So it could be public, it could be internal, it could be wherever. So the next part is actually to create the Streamlit, which is the front end of the application, really. And that's it. And if we dash back over here, this has just built that container too in that short of a time. Now you'll notice that we've got the little arrows here for opening front ends. So this is where we access the last application. These ones don't have them because they're all internal services, if you like. But the Streamlit is talking. You can see the arrow here. It's pointing towards this group. The Milvus Vector Database talks to the storage, also to the ETC database. But to get access to the system, we can click that one. We could also do a command line or do anything to get this URL to tell us how to access the application. Okay. So at the moment, it's loading the PDF that was in the YAML file. So in the YAML file, we said go off to this S3 storage using the Minio, and it's going to load that into the vector database. So it's a book that was created by AI. So nobody's written it. It's not on the internet. We know that because we got AI to do it internally. And it's actually it's written a fictional book that nobody else knows about. So when we ask it questions, then the answers haven't come from that large language model or the training that we spoke about before. It's actually gone off and read the book to try and understand that book, so you can ask it any question on it. So it's downloaded it, it's processing it. Right, okay, it's all ready. So we can ask questions now about that book. So on the website, okay, you got the link. I've already shared it. So that'll be passed out to you in no time at all. This is the book that we had AI write, and that's why we know until I just shared it on my website, it's kind of not on the internet. So if we, for instance, ask it, who is the starfish and how do you know the answer? Now, we don't know that because we haven't read the book, right? But if we ask this will go into the large language model. It will talk to the Streamlit application, go off to the vector database. It's gone off and read all the words in that book, and it's grouped it in small chunk sizes. And the response that you get back can depend on how big or small the chunk size is. So it could read like 5 words at a time and put that in a little bank, or 500 words at a time. Anyway, it's going to go off, and hopefully it's going to tell us who the starfish is in this book and how to know that. So just when that comes back, I'm going to do a search for starfish in the book. Right, okay. So the answer, we asked it, who's the starfish and how do you know it? The answer has been Sarah is the starfish. The information is found in the book, The Forgotten Lighthouse. where her grandfather addresses her as my little starfish in the letter. And if we go to the book that I've shared on there as well, we can see if we do a search for starfish, it says, "I love you, my little starfish, be brave." Now, at no point does it actually say in the book that he's referring to his granddaughter when he does this. So it's actually had to go off and read the book and fundamentally understand what it's talking about to know that he's referring to Sarah when he says starfish there at the end. And so it's quite clever. There's another reference to it here. I'm sorry I couldn't prepare you for this, my little starfish, but you were the last of our time, and the responsibility falls to you to know. So, you know, it's actually had to go off and understand the book, which is really quite clever. Right? Now, I've also added a list of questions which you can ask it when you can write. So if you've got a Power 10 and you can run RHEL, a Linux, Alpha and OpenShift on this, then you can do this today, tomorrow, for free of charge. It's all open source. It's all freely available on GitHub. The tutorials on my website. So you've got your own ChatGPT or Claude or whatever that you can use at 18. I think we see between 16 and 30 tokens per second of the speed, but it's faster than I can read it. So that's, you know, sort of okay for me. And as we go through the slides a little bit, you can see where we've compiled and we've tuned a lot of the software that's used for this for Power 10 and MMA, because that's where the benefits coming from, MMA within the Power 10 chip. And that's why when we were talking earlier, yes, you can do it on Power 9. Probably wouldn't want to, because it will be so much slower because the MMA gives it all those benefits. So Daniel, Jason and Rodrigo all instructed this class with me. Daniel's my peer colleague in New York and Jason's in China. Rodrigo works for Expert Lab Services. So he pinged me the other day and he's doing something similar to this for a UK client. But by all means, that's now publicly available to you. And if you want to take it a step further, there's a couple of slides later how we can do that. But you know, get in touch, and it's really simple. If you get OpenShift installed with the single node node that we talked about earlier this morning, which will help you if you want and do that with you. It doesn't have to be a single node. It could be, but you know, it's like a 5-minute exercise to get this up and running, and then we can run workshops or get client engineering to help in real world use cases. So connecting it up to your data